At Radford Motors, 4050 trucks were sold. Of the trucks sold, 32% were white, 24% were gray, and 44% were black. How many white trucks were sold? Okay, very straightforward. White trucks is 32%, so it would be 0.32 times the total number of trucks, which is 4050, and that is 1296. If 1/4 of the gray trucks sold were electric, how many trucks sold were both gray and electric? So first we will figure out how many were gray, and that's 24%. So 24 times the 4050. So that is 972. So 972 are gray. And of those 972, 25%, 1/4, would be electric. So 0.25 times that 972, and that would be 243. In addition to the 4050 trucks that were sold, there were K unsold trucks, all of which were black. In total, 46% of all trucks sold and unsold were black. Determine the value of K. So 4050 were the ones sold, and K is unsold. And they're saying that all of the ones that were unsold were black. Okay, so K represents, well, all of K is black. So what percentage of these guys were black? That would be 44%. So 0.44 times 4050, which is 1782. And so now we get to what they're asking, which is 46% of all trucks, sold or unsold, were black. So that means 0.46 is a following fraction. The total of the black trucks is 1782 plus K, and the total of all the trucks is the 4050 plus K. And that's our equation. So cross multiply, and you will get 1782 plus K is equal to 1863 plus 0.46K, and therefore 0.54K is 81, and therefore K is 150. For a positive 3-digit integer, f at n is equal to the sum of n and the digits of n. For example, f at 351 is 351 plus 3 plus 5 plus 1, which is 360. What is the value of f132? All right, so that by definition would be the 132 plus the sum of the digits, was a 1 plus 3 plus 2, and that is 138. If f at n is 175, what is the value of n? Okay, this one is a little bit different. Now we have to go, I guess, in backwards, reverse. First we have to identify an n. It's a 3-digit integer, and therefore n would be 100a plus 10b plus c, and this is what the sort of the node is kind of getting at. And then that, of course, plus the a plus the b plus the c, and that is equal to 175. So that's the equation that you would have to work with. Okay, let's see how far we can go with this equation. Not very far, probably. 101a plus 11b plus 2c, and that's about it. And that's it. So we only have one equation, but we have 3 variables, so obviously we're going to have to do some inspection here. But the good news is that we can kind of guess perhaps at least what a could be. A cannot be 0, because if a was 0, that would no longer be a 3-digit number. So a is not going to be 0. A could be 1. Okay, that's a pretty good estimate for what a is, but a cannot be 2. So why? Well, because if a was 2, then this would be 2 something, right? 200 and something. And therefore f at n would be greater than 200. If you take that number 200 and then add to it a couple other numbers, you know, you're adding the 2, then you're adding the b, and then adding the c, then of course it'd be over 200, and this is 175. So I am confident that the only thing a could be is 1. So that helps us out quite a bit, because then that just becomes 101 times 1, and then we're down to 2 variables, which is of course better than 3. So this becomes 11b plus 2c is 175 minus 101, which is 74. Okay, at this point, we of course now have to use our inspection. So let's see. Let's just start with some values here. If C is, how would I approach this now? Let's see here. Well, let's see. If C is 0, then that would mean B would be 74 divided by 11. And that would be, that's not going to be an integer, so that's out. If C is 1, then that becomes 72 divided by 11, correct? And again, B becomes some sort of integer. Okay, let's keep going, not a problem. If C is 2, then that's going to be 74, if C is 2, yeah. And you kind of keep going like that. And I'm trying to think, it's probably better just to figure out what B could be. Like, it's going to be, obviously, we're going to have a multiple of 11 going into 74. So 74 divided by 11 is about 6.7, right? Which is what we did there. So let's try 6, because obviously, you know, it's coming down to 6. If B is 6, that's going to be 66. And therefore, 74 minus 66 is 8, and C would be 4. Aha. Now, see, a little bit of trial and error is all it takes to kind of figure this out. So that means n is equal to 164. And then I encourage you to figure out the actual f at n, like manually, to verify that it indeed is 175. If f at n is 204, determine all possible values of n. Okay, so by now you are an expert on how to do these questions. So just like before, we'll set it up, and then we will do our trial and error and see what happens. So we got 204 is equal to 101a plus 11b plus 2c. Okay, so just like before, I'm going to make a sort of a guess as to what a could be, and then what b and c will calculate those. Well, a cannot be 0 for the same reason as before. It's got to be a 3-digit number, and n is equal to abc. Correct? So it's not 0. So let's try 1. If it's 1, it would be 204 is equal to 101 times 1 plus, hold on. Oh, I'm so caught up in the last question I just did. Well, hold on. Did I do this right? I think I messed it all up because I'm so caught up in the last question. Sorry. It would be, hold on here. Well, actually, no, that's right. I think, let me see here. Why does it look the same to me? 101a plus 11b plus 2c. Yeah, I think that's right. But this is 204. Well, I guess it's right. I'm just getting a little suspicious as to why it looks identical. But if it's identical, it shouldn't be that a big deal. Okay, so let's do this. So that would be 103 is 11b plus 2c. Okay. All right, so I'm confident that that is correct. Okay, so same story as before. We're going to figure out what B and C are. So, well, let's see here. Just like before, let's divide 103 by 11 and see what happens. That's about 103 by 11 divided by 11 is about 9 point something. So let's try 9 for B and see what happens. If that's 9, that'd be 99. So that would be 103 minus 99, which is 4. So C would be 2. Yeah, so that works. Great. That works. And then similarly, you can try other values to see if it works or not. But I think that's the only one. Now we can go to a equals 2. Because a equals 2 before was in the previous part was not possible. But in this part it is possible because this is 204. And I think that is what was making me think that there's got to be something different. And there is something different, is that we will get a second value for a. And that's what my brain was thinking. Okay, so then that means this is 204, 101, and 2 this time. 11b plus 2c. So that becomes 202. So that's just 2 and 11b plus 2c. And then since a, b, and c are positive digits, the b has to be 0 and then c has to be 1. So our two values for n are 192 and 201. In the diagram, ABCD is a square with a side length of 12. The midpoint of AD is E. BE intersects AC at F. Circle with diameter BE passes through A and intersects AC at G. What are the coordinates of F? Well, I think the coordinates of f will be figured out by looking at the intersection of EB, lines EB, and AG or AC, whatever you want to call it. Right? Okay, that shouldn't be too big of a deal here. Let's figure out the line AC. Well, that's y equals x, and you can easily figure that out. And then the other line, which is EB, take a little bit of work. First, figure out the slope, which would be rise over run, 6 minus 0, 0 minus 12. So that's negative 1/2. And then y, therefore, is equal to minus 1/2 x plus b. And then, therefore, b, well, we can substitute any of those points. So substitute, let's say, 0, 6. So 6 minus 1/2, 0 plus b. So b is 6. So therefore, that equation is y is equal to minus 1/2 x plus 6. So set that equal to that, and you'll get your point f. So you'll get minus 1/2 x plus 6 is equal to x. And when you solve for this, you will get 6 is equal to 1.5x, and therefore x is equal to, well, hold on. Yeah, that's correct. So x is equal to 4, and then sub it back into either one of these, and that's pretty easy. Y is equal to 4. So point F is 4, 4. What is the area of AEF? AEF. Okay. AEF. Well, that red line I drew, we can sort of call the height. And that height would be the x-coordinate of f, which is 4. So therefore, the area would be 1/2 base times height. The base is from E to A, which is 6. And the height, I've just told you, is 4. So that's going to be 12. Determine the area of quadrilateral GDEF. GDEF. First of all, where is GDEF? What is that? So I've got to connect, first of all, G to D to actually make that some sort of a shape. Okay. And then now I've got to figure out GDEF. Okay. What I believe is GDEF is equivalent to the triangle CDA minus triangle CGD minus triangle AEF. CDA, which would be the big one, the sort of the half of the square, and then from that you subtract two smaller triangles, CGD, and then the one downstairs, AEF. Okay, so CDA, the big one, that's just 1/2 base times height, which is 12 times 12. That's pretty straightforward. And then CGD, 1/2 base times height, 1/2. The base is 12, and the height, the height I don't know, which is going from here to here. That height I don't know. Okay, so I'll leave that blank for now. And then minus AEF. Well, AEF, didn't we just do that? It's right here, right? 12? So then we just put that minus 12. Okay, so that looks like pretty doable. That's 72 minus 6 times the height and minus 12. Okay, so I guess I have to figure out that height. Okay, so that's the big... Okay, so how do I do that? Well, G, it would be... I'd have to figure out the coordinates of G, and then I can figure out that distance. And to figure out the coordinates of G, it is the intersection of that line AC and the equation of the circle. Correct? Yeah. Okay, well, line AC is y equals x. That one actually we did previously. Now I have to figure out the equation of the circle. Okay. I got it. And there's something that they mentioned in this question that's very important. The circle with diameter BE. So BE is the diameter. That's actually a very important point. Because since BE is the diameter, the midpoint of that would be the center of the circle. Correct? Yeah. So BE is the diameter. So the midpoint of that would be the circle's center. So that midpoint is just 12 plus 0 divided by 2, and then 0 plus 6 divided by 2. So that's just 6, 3. Okay, that's very, very important. And I think we have to figure out the radius. So since BE is the diameter, BE, we need to figure out its length. So BE squared is going to be using Pythagoras 6 squared plus 12 squared. And then therefore we will calculate BE squared would be 180. So BE would be root 180. And then the radius would be half of that. So the radius would be half of that. Root 180 is what? 6 root 5. So then the radius would be 3 root 5. Okay. And then they also gave us this nice little tip, just in case you had forgotten, that a circle with center HK with radius R has that equation. So just apply that to what we just found out, and we will get the following equation: x minus 6 squared plus y minus 3 squared is equal to 45. R squared. So this guy squared, so it'll be 9 times 5. Okay, so we got it. We have this, and we just find the intersection. So plug this guy into there. So that'd be x minus 6 squared plus x minus 3 squared is 45. Expand, collect like terms, all that stuff. X squared minus 12x plus 36 plus x squared minus 9x plus 9 is equal to 45. And then let's see here. If you collect like terms, you get 2x squared minus 20. Hold on. Let me see if I did this right. Oh, sorry. 6x. Can't make those mistakes. So that's going to be 18x. And 40. This is 45. That's 45. Okay, that's easy. 45's cancel. Divide through by 2. X squared minus 9x is 0. So therefore x minus 9 is 0. So x would be equal to 9. So that means y is equal to 9 since y is equal to x. So G, the coordinates for G, are 9, 9. If I have not done anything wrong. Okay, that finally allows me to figure out the distance for that height. Now be careful though, because the distance, that red line that I drew, it's not 9. 9 is here, the y coordinate. And then we got to subtract from 12, 9 in order to get that distance. So that distance would be 12 minus 9, and that's 3, of course. So 3 is what goes here. So there'd be 72 minus 18 minus 12, and that is 42. A Hewitt number is a positive integer that is the sum of the cubes of 3 consecutive positive integers. The smallest Hewitt number is 1 cubed plus 2 cubed plus 3 cubed, which is 36. How many Hewitt numbers between 10,000 and 100,000 are divisible by 10? All right. Well, a Hewitt number looks to me like it is of the form a to the power of 3 plus b to the power of 3 plus c to the power of 3, like that. Right? We'll call it Hn for Hewitt number. Okay. And we want that to be divisible by 10. All right. So how is that even possible? Well, one of these... Well, one of these, A, B, or C, if it's a multiple of 10, that would work. So, for example, if B was 10, that takes care of B, but then what is A and B? So then let's just look at A cubed plus C cubed. How would that be then a multiple of 10 also in order for the sum to be a multiple of 10? Well, the first thing I'll do is I will factor this, and you guys may remember how to factor it. It would be A plus B, A squared minus AB plus B squared. Now, if these two guys, or sorry, I should have put in the C there, because I'm working with A and C. So A plus C times A squared plus minus AC plus C squared. That's the right way of doing it. Okay, so if this guy right here were to be a sum that is a multiple of 10, that would work. And I think that's possible if A, for example, is 9, right? And then C is 11. Because they're consecutive, right? Yeah, they're 3 consecutive positive integers. So that would, in this case, make this 9 plus 11. And then this part here I don't really care about, because that becomes 20, and you can multiply 20 by anything, and it's still going to be a multiple of 10, because 20 is obviously 2 times 10. So we got a multiple of 10. So my conclusion is that any scenario like this, where the B is a multiple of 10, and then A and C are obviously, you know, on either side, so that would work. And yeah, I'm pretty confident. And then similarly, if B is 30, A is 29, and C is 31, and so on. I mean, it's infinite. But they give us a range here. So because we are given a range, we will have to see if it falls within the range. So first, let's figure out this one. This Hewitt number would be 9 cubed plus 10 cubed plus 11 cubed. And let's see, what is that? That is 3060. Okay, is that in that range? No. Okay, so that's not, even though it is divisible by 10, it's not in that range, so we have to keep going. This Hewitt number would be 19 cubed plus 20 cubed plus 21 cubed. And that is 24120, and that is in that range. So, okay, we got one. This Hewitt number would be 29 cubed plus 30 cubed plus 31 cubed, and that is 81180. Again, yes, good job. And then I'm confident that the next one will fall outside. It will be greater than 100,000. So that means we only got 2. Oh, surprisingly, I thought it would be more than that, but 2 is the answer to that question. Determine how many of the smallest 2024 Hewitt numbers are divisible by 216. Well, what we need to do, first of all, is get sort of a general formula for a Hewitt number. Now, what is a Hewitt number? It's the cube of 3 consecutive positive integers, right? So we'll let those integers be n minus 1, n plus 1. Those are indeed 3 positive consecutive integers, as long as n is positive, or n is greater than 2 or something like that. Well, whatever. So then you expand this whole thing out, and let's see what we get. So we get n cubed minus 3n squared plus 3n minus 1 plus n cubed plus n cubed plus 3n squared plus 3n plus 1. Okay, collect like terms, and we get 3n cubed minus 6 plus 6n, I think. Is it plus? Yes, plus. And then we can factor this 3n n squared plus 2. Okay, so that's a pretty good formula for a Hewitt number. So we now want this Hewitt number to be divisible by 216. So that means that 3n times n squared plus 2 is some multiple of 216. We'll just call it 216 times k. And that is basically what we have to deal with here. So that is the heart of the question. So here we go. And I think this is going to be, my guess is this is going to involve some scenarios here. So here we go. 3n times n squared plus 2. Now 216, we're going to have to break that up into its prime factors, and that is 2 to the power of 3 times 3 to the power of 3, I believe, and times k. This 3 we can get rid of, and then that's going to just give me 2 to the power of 3 times 3 to the power of 2. And therefore, since this is 8, then that means this whole side must be divisible by 8. So n times n squared plus 2 is divisible by 8. And if that's the case, then that means then n must be even. So n must be even. And if that's the case, let n equal something even that is guaranteed to be even, 2a, right? Anything of the form 2a is even. And let's plug that back into this formula. We get 2a all squared plus 2 is equal to 2 to the power 3, 3 to the power 2 times k. So that's going to be 2a times 4a squared plus 2 is equal to, well, the same thing. I mean, that side doesn't change. So let's see, can I factor out a 2? If I do, that'll be 4a, and that's going to be, oh wait, hold on. Factor out a 2, right? Carefully, if I take out a 2, that's going to become 4a, and then that would be 2a squared plus 1. Correct? Yeah. Which is 2 to the power 3 times 3 squared times k. Okay, so that means that n actually can also equal 4a. So that means that n is divisible by 4. Okay, that's a pretty good finding. And then going back to the original guy, which is right here, we can also conclude, we have that conclusion, we can also conclude that n times n squared plus 2 is divisible by 9, right? Because of that's 3 squared. So, in summary, we can have, think a few scenarios here. We have to figure out which one is actually going to work. The first one is that n is divisible by 3 and n squared plus 2 is divisible by 3. So that's talking about this guy right here. So if they're both divisible by 3, the product will be divisible by 9. That's the first scenario. The second scenario is if the second, just concentrating on this right here. I'm just going to concentrate on this for now. The second scenario is if just n is divisible by 9. And the third scenario would be just the n squared plus 2 is divisible by 9. Yeah. Okay, so we got those three for this guy right here. Now, of course, we have to look at the other one, which is n is divisible by 4. This one. So we have to do a little bit more exploration with these three guys. Okay, so let's try that. Well, let's look at part 1. If n is divisible by 3, let n equal 3b. And therefore that would make this equation, which one here? This equation right here, the very, very original one, 3 times 3b times 3b all squared plus 2 is equal to 216k. And then that's 9b is equal to 9b squared plus 2 is 216k. Now, if 9b plus 2, this guy is not divisible by 9 for obvious reasons. It's 2 more than a multiple of 9. So not divisible by 9. And therefore, if it's not divisible by 9, it's not divisible by 3 either. So that means that n squared plus 2 guy can't be divisible by 3. So therefore 1 is not true. You can't have both n divisible by 3 and n squared plus 2 divisible by 3. You probably could have just figured that out without even substituting it into the formula. Because if n is a multiple of 3, n squared plus 2 is not going to be a multiple of 3. right? Because 2 more than a multiple of 3. It would have to be 3 more than a multiple of 3 to be divisible by 3. Okay, well, whatever. Let's move on here. Let's move on to this guy, the second part, and the third part. Let's see. This time we're trying to get divisible by 9. So for part 2, n is divisible by 9, so let it equal 9b. And then this time when we plug it in, it becomes 3 times 9b times 9b squared plus 2 is equal to 216k. So that is the same kind of story, really. That's 2 more than a multiple of 9, right? Because it's going to be 81b squared plus 2. And therefore, this is not divisible by 9, since it's 2 more than a multiple of 9. So if one is true, the other one cannot be. So therefore, 2 and 3 both can't be true. We can have one or the other. Because if 9 is divisible by, if n is divisible by 9, n squared plus 2 will not be. And if n squared plus 2 is divisible by 9, n will not be. It's sort of vice versa, like one or the other type of scenario. So we have to now come to a conclusion, and our conclusion is as follows, that we can either have, so summarizing, we have n is divisible by 4, this guy right here, and either we have 2 or we have 3. We can't have both. So n is divisible by 4 and n is divisible by 9, or n is divisible by 4 and n squared plus 2 is divisible by 9. So those are our two possibilities. So let's put those there. So n is divisible by 4 and n is divisible by 9. That's our first one. And our second one is that n is divisible by 4 and the n squared plus 2 guy. Yeah, n squared plus 2 is divisible by 9. So those will be, I think those will be the ones that we figure out. All right, so let's explore this. The first one, n divisible by 4 and n divisible by 9. So if n is divisible by both 4 and 9, it would be divisible by the product, which is 4 times 9, which is 36. So therefore n would be 36k. Or it doesn't really matter. I know I used k before. You can use any letter you want, really. So they had given us a parameters, right? It's so long ago. 2024 Hewitt numbers. Yeah. So remember, our integers were n minus 1, n, and n plus 1. So the Hewitt number the first 2024 Hewitt numbers. So the very first one would be when n is 2, correct? Because it'd be 1, 2, and 3. So that's the first Hewitt number. So the 2024 one would be when n is 2025. And then this would be 2024. And this would be 2026. Okay, so that means n is between 2 and 2025. And then we have put 36k. We had figured out that would be our value. So then now we can just divide through. So this would be 2 over 36 is less than or equal to k, and that would be 2025 over 36. So k, since k is an integer, it's going to be between 1 and 56. So for every value of k, you'd get one Hewitt number, and that's obviously 56 values. All right, so that's pretty good progress. And now we will tackle this guy here. Okay, so we have this time n is divisible by 4. So n, let's call it 4 something, 4m. And then n squared plus 2 is divisible by 9. So we'll call it, well, actually, let me just put the 4m first and see what that gives me. So it'll be 4m all squared plus 2, and that's 16m squared plus 2. And 16m squared plus 2 is going to be has to be divisible by 9. All right. Well, m, in terms of a multiple of 9, is 9q plus r. It's either a multiple of 9 or it's not. If it's a multiple of 9, it's just 9q where r is 0. But if it's not, then it'd have some remainder. And the remainder obviously would be anywhere between 0 and 8. So the value for r and the remainder that's going to be something we have to check on. So the value for r is between 0 and 8, right? And then the remainder, when 16r squared plus 2 is divided by 9, but first let's show that. Actually, we need to show the math there. So this guy right here, we got to plug in the m, otherwise it won't make any sense. So we're going to plug in 16m squared plus 2. So 16m is 9q plus r squared plus the 2. So that's going to be 16m squared plus 2. And that's, let's see here. And when you expand it out and arrange it like that, you will get this. So that basically means that this whole expression here is equal to that. And that 16m squared plus 2, which is basically a representation of n squared plus 1, has to be divisible by 9. And since this is already divisible by 9, this end part, that 16r squared plus 2, has to be divisible by 9. So that means that 16r squared plus 2 has to be divisible by 9 in order for this to work. So then we have to figure out the remainders when 16r squared plus 2 is divisible by 9 for each value of r, right? And then we will get 2, 0, 3, 2, 6, 6, 2, 3, and 0. So the only time it's divisible is when the remainder is 0. So this guy and this guy. So that happens when r is equal to 1 or 8. So if that means that n is 4m and m is 9q plus r, so that would be 9q plus 1, or n is equal to 4m, which is 4 times 9q plus 8. Okay, there you go. Those are the values for n. So just as before, as we used that, we can do that again this time. So as before, n was between 2 and 2025. So first let's do it for this guy and then for this guy. So n is 4 times 9q plus 1, 2025, and like that. Okay, so then I'll let you guys figure out for q. You just have to, divide through by 4, subtract 1, and divide by 9 and all that stuff. That's very straightforward. And when you do, you'll get 56.1. So therefore, this would give you 57 values, 0 to 56 inclusive. And then for this guy, that guy, same kind of story. 2025. This time it would be 4 and 9q plus 8, and then again divide through by divide through by 4, subtract 8 and divide by 9, and you will get the following. 0 less than q less than 55. And therefore, from 0 to 55 inclusive, that's 56 values. So the grand total, after all that, this 56, that 57, that 56, 56 plus 57 plus 56, and that is 169. Consider the following statement. There are two distinct Hewitt numbers whose sum is equal to 9 times 2 to the power of k for some positive integer k. Show that this statement is true by finding two such Hewitt numbers, or prove that it is false by demonstrating that there cannot be two such Hewitt numbers. Well, we go right back to our original formula that we had figured out earlier on, that the Hewitt number would be of the form 3n times n squared plus 2. Correct? And we have this time Hewitt number 1 and a Hewitt number 2, and they're saying its sum is equal to 9 times 2 to the power of k. Okay? Well, we'll use n for one and m, the letter m, for the other. And then since we had previously figured out that 2 has got to be the smallest, and we'll just make n greater than m, and then we'll put that in. So hn1 I will figure out with, it doesn't really matter, n, and the other one with m. So this will be 3n times n squared plus 2, and this will be 3m times m squared plus 2. And that's equal to 9 times 2 to the power of k. Correct? Okay, so here we go. We got a lot of algebra here. So first let's divide through by n and then multiply out. So that'd be n cubed plus 2n plus m cubed plus 2m. And then since we divided through by 3, that just becomes 3 times 2 to the power of k. And then the n cubed and m cubed I'll group together, and then the 2n plus m, I'll just do a little bit of factoring there. And then this guy, we had previously put a formula in, which I hope you remember. That can be factored as n plus m times n squared minus nm plus m squared. And then this remainder stays the same, all the other stuff. And then now we can factor this guy. So we have n plus m on both terms, so this will be n squared minus nm plus m squared plus 2. And I think that's about as far as we can go there. Yeah. Okay, so this side here obviously is even, because that side is even because it has some power of 2. That 3 is there, but it's going to be multiplied by some power of 2, so that means everything's got to be even. So we have to look at something called parity. The parity of n and m. And then what would therefore be n plus m, and then what would therefore be that big long n squared minus nm plus m squared plus 2. Because we want the end result to be even. So let's see. Let's make a little table, and you can first experiment with a couple of values, like numbers, and just if you're unsure, because you may not be able to figure it out in your head. So we got odd and odd. That's one possible choice. We have odd and even for n and m. We have even and odd. And finally we have both even. So for example, I mean, maybe you can do it in your head. I certainly can't, especially for this long one. So let's just use some numbers first of all. Let's say they're both odd. So let's say they're something like whatever. Odd would be, let's try 1 and 3 for the values of n and m. Well, the sum is even. And then you can do this one. That'll be what? 1 squared minus 1 times 3. plus 9 plus 2, so that's what, 12 minus 3 is 9, so that's odd. You see what I mean? You can just use tiny little numbers to figure out. And if you do that, you'll find that this becomes odd, that's odd, that's odd, that's odd, and these are both even. Alright, so now we have a conclusion that the only way that this expression can be even, because of that 2 to the power of k, is if at least one of these two guys is even. And that seems to be this scenario and this scenario. So these are the two scenarios for the parity of n and m. Either n and m are both odd, or n and m are both even. Okay, so we will work with those. So the first is both n and m both odd, and the other one, n, m, are both even. And that should give us our conclusion of whether or not we can find two Hewitt numbers like this. Okay, both odd. So let's see here. If they're both odd, and we know that the way we set it up was that n is greater than m. So let's just use the smallest ones. Let's just experiment what's going to happen. So the smallest odd would be m equals 3 and n equals 5, right? So therefore, n plus m would be 8, okay? And then that n squared minus nm plus m squared plus 2, that is going to be, let's see here. Well, what is n? N is 5. So 5 squared minus 3 times 5, 15, plus 9 plus 2. That's 25 minus 10. 10 plus 11, 11. So that's going to be 21. So this is going to be, the smallest it could ever be is 21. So it's got to be greater than or equal to 21. All right. So we were told that this big expression, right? So that means that this thing, n plus m times n squared minus nm plus m squared plus 2, that has to equal 3 times 2 to the power of k. Correct? Now, since n plus m is even, that we have figured out, actually we figured that out up here, this has to be odd, that n, that whole big long one. So on this side, that's the even part, so that's the 2 to the k part, and on this side, that's the odd part, so this guy has to be 3. Yeah. Or it could be 1, and you know, it could be either 2 to the power of k, or it could be 3 times 2 to the power of k. So let's explore those two scenarios. If n squared minus nm plus m squared plus 2 is greater than or equal to 21, then there's no way it could ever be 1 or 3. So that falls apart. So this scenario basically gives us no possible solution. Okay, so far we haven't been able to get anything. So let's see what happens here. Maybe this will work. This time we're saying that they're both even. So if they're both even, let's just call them 2a and 2b, right? That's what even means. And then we go right back to that 2 to the power of k, and then that whole big long nm times the n squared minus nm plus m squared plus 2. 2a plus 2b, and then 4b squared. I'm substituting now. 4ab plus 4a squared plus 2. And then let's see here. I can expand this a little bit. 3 times 2k. I can factor out a 2 and a 2. 2 from here, 2 from there. And that would be therefore 4. That would be a plus b and that would be 2b squared minus 2ab plus 2a squared plus 1. So this looks to me like it's the odd guy because it's a bunch of 2's plus a 1. So like it can't be even. And then therefore this obviously has to therefore be the even one. So this has to be the 2k or the 3 times 2k. And this guy, this side, has to be either the 1 or the 3. Very similar to last time. Okay, I think we're getting somewhere. So therefore, let's see here. What's our next step? Well, just going back to the original definition of m and n, and then we can sub in these values. So 2 is less than 2b is less than 2a, so therefore 1 is less than b less than a. Is that right? Sorry, I made a little mistake here. This should have been n is 2b, and this should have been m is 2a. Sorry about that. I just noticed that when I looked up here for this term. It's n squared, so there would be 2b squared, which is 4b squared. Well, it's a good thing I caught it, and therefore this is going to be 2a, and that's going to be 2b, so therefore be 1a less than b. So now let's proceed with this, and therefore let's again use the smallest one. A, the smallest, they're both even, correct? Yeah, they're both even. So the smallest numbers are a equals 1, b equals 2, and therefore that would make m equal to 2 and n equal to 4. Yeah, and these of course are both even. So therefore that n squared minus nm plus m squared plus 2, that expression, using our values of 2 and 4, would be, let's see here, 4 squared, which is 16, minus 2 times 4, which is 8, plus 4 plus 2, and that looks to me like 8 plus 6, which is 14. Okay, so that obviously cannot be odd, but let's do that again. Actually, I actually want to do a little bit more specifically on this term here with b and a, because that term is actually 2b squared minus 2ab plus 2a squared plus 1, and that therefore using a, 1 and 2 would be 2 times 2 times 2 is 8 minus 4 plus 2 plus 1, and that looks to me like 7. So that means that this expression has got to be greater than or equal to 7, and therefore there's no way it could be 1 or 3. And therefore it cannot be 1 or 3. So it falls apart again. So therefore, in grand conclusion, therefore, there are no two Hewitt numbers that sum to 9 times 2 to the power of k.